Hey everybody, Mr. Wada, and I'd like to go over today's assignment. So at this point, we've gone over how to name ionic compounds, how to name covalent compounds, or molecular compounds, as they're also called. And we've gone over how to figure out what charges atoms make. We've gone over why they make those charges. We figured out how many bonds different atoms can make, different elements make. And we've gone through all the different combinations of those ideas. And the final part to this is to put them all together and to see what we can do when you have all the stuff mixed together. So for this week, you have a combination of ionic and covalent compounds over here. And then you're also going to have formulas, or formulae is the actual plural. And you're going to have to figure out if it's ionic or covalent and then go from there. The reason why we're doing it this way is if you can identify if something is ionic or covalent, then you know how it's going to be named. And you also know how the charges are going to work out, or whether they actually work out like that. For example, some of these, the charges may not make perfect sense, because if everything is a nonmetal, then it means everything is going to be neutral or have a negative charge. And it wouldn't make sense for everything to keep adding up negative charges. Like we know that O2 is how you would find oxygen. That would be -4 if you put them together. So they don't use charges because covalent compounds don't care about charges the same way. So anyways, the easiest way to tell if something is ionic or covalent is if you have a metal and nonmetal, that'd be ionic. And if you have two nonmetals, that's covalent. So basically, if you're on the right side of this line here, I call it the staircase. You can call it whatever you want, but I call it the staircase. If your elements are to the right of that, that's going to mean it's made of two nonmetals, it's covalent. If you have one from over here and the other is from over here, that means you have something that is ionic. And the reason for why is because the things on the left side of this are good at giving away electrons, which is why they're positive. If you give away negatives, that makes you positive, because you have less negatives. Minus negative is positive. And if you're on the right side, they are good at accepting electrons, meaning they're gaining negative charges because electrons are negative. So anyways, so for the first example here, it's got a formula of H2O2. And I need to know whether or not I should be using the ionic or covalent nomenclature. That's naming. Well, if you take a look, hydrogen and oxygen are both nonmetals. Oxygen's right here. And although hydrogen is here, we know it's a gas, and it also shows up over here on the right side. Hydrogen is weird because it acts sort of like a metal sometimes, but we know that hydrogen is not a metal. You collect it as a gas in a tank made of metal. So it's not the metal itself. So anyways, that means it is covalent. Remember the prefixes. Ionic doesn't use prefixes and covalent does. So if this, H2O2, uses prefixes, that's dihydrogen, dioxide. Oxide is over here, hydrogen's over here. Okay. And that is covalent. On the second example, right here, we have manganese 4 selenide. Okay, so first we need to find manganese. Manganese is right here, element 25. It can be +2 or +4. This 4 right here is telling us it's a +4. Okay, why does that matter? That matters because if this is an ionic compound and it's got the metal ion that can make more than one charge, we need to know the charge so we can figure out how many of the other element we need. So right now we've got +4 for the manganese. And selenide, element 34, selenium, its ion is called selenide. That has a -2 charge. Okay, so if manganese is +4 and selenide is -2, that would mean we need 2 selenides to cancel out the 1 manganese. So this charge here, the +4 part, was important because it told us how many of the selenium we actually needed. If this was manganese 2, we would only need 1 of each because they would be the same charge, plus and minus. And that is obviously ionic because if you look on the right side, we've got selenide right here on the right side of the staircase, and our manganese is on the left side of the staircase. It's a metal. All right, so This pulls all those ideas from the past couple weeks together. Give it your best shot. As always, if you have questions, feel free to email me or leave a comment in Google Classroom.